In this video, we're going to see how we can do basic area configuration for ISIS on Cisco IOS XR. Remember that when we're using protocols such as OSPF or protocols such as ISIS, areas gives us the ability of continuing to scale, of having our designs and separating our network into logical units, logical areas where we will have a subset of devices. Then we will have devices that will act as border, and they will announce whatever exists in that area into our backbone area. This allows us to scale much more than we could if, for example, we have all devices in the same area, and every time a single device has any sort of event that triggers the database to change, that will trigger all the devices everywhere to run the shortest path first, depending on the change, because there's optimizations to do incremental SPF and partial SPF. But the point being that areas allow us to scale. So they're very popular in any modern network that deploys OSPF or ISIS. So the idea here is to see how we could take a network, the topology that we have, where we have all devices in the same area, and kind of separate them and see with ISIS on XR what happens, what's the change, what information now the devices that live in the area get, etc. So with this in mind, let's go ahead, let's see what our topology is, and let's see what we want to do with it. So this is the topology that we have. We have our three routers, and now they're all in a single area. But what we want to do is we want to have them in two areas, for example. We want to put router 1 and 2 in area 1, 2, and we want to put router 3 in area 3. What's going to happen here is that we will need to add some configuration. So this link here, because remember that by default on XR, the interfaces will be level 1 and level 2 capable. This means that router 1 and router 2 here will form a level 1 and a level 2 adjacency. This means that the backbone will be extended to router 1. And for what we want to do, let's say we don't want to do this. We want to only have router 2 and router 3 in the backbone. And this will allow us to see how does getting out of the area looks like for router 1. And this is the whole concept of router 1 signaling that he is a border device, and that everyone in that particular area can send traffic to him, because he will put the attach bit into his LSPs. Router 3 will be, since router 2 and router 3 will be will be on different areas, because router 2 will belong to area 12 and router 3 will belong to area 3. The only way that they're going to have communicating with each other will be by a level 2 adjacency. So we're going to have a level 2 adjacency here. And this we won't have to configure. This will be just a protocol making sure. Because like I said, we can't have devices from different areas forming a level 1 adjacency. That doesn't really work. So here, even though router 2 and router 3 will be level 1 and level 2 capable, because of the fact that we're going to be in different areas, they're only going to form a level 2 adjacency. So let's jump into our topology and start doing this configuration, and we'll verify that in the end we have router 1 and 2 in a separate area from router 3. The router 1 only has a level 1 adjacency with router 2, and we'll see the ISIS database, and we'll see what happens, how does it look like from the perspective of router 1. And how does it look like also from the perspective of router 2, because remember, the interesting thing is that here router 1 will end up with only the link state for area 1, 2. Router 2 will end up with a link state of area 1, 2, and he will end up with a link state for the backbone. In the case of router 3, he will end up also with a link state of the backbone, and he will end up with a link state of his area 3. Because his loopback and the interface that goes between router 3 and router 2, if we don't change it, if we don't make it, we explicitly tell iOS, we explicitly tell the XR, router 3, this link is only going to be level 2, then he's also going to be in his level 1 database, which is obviously something that would be desirable in case we had other routers to his area, which is usually the case. Usually in an area, depending on the size of your network, you have multiple routers. The exact number is, defined, depends on your area, depends on your network, but we won't have, or it will be odd that we have a single device in a single area. We will have multiple devices. This can be used as a geographic type of configuration where you could have devices for a particular city in an area. Okay, so let's go to router 1. Let's go to router 1. So here we are on router 1. I always like to check that the devices are in the state that we expect them to be. Then it usually saves up some troubleshooting later on after we have changed the configuration. So let's check that he's learning information from ISIS. He should probably know about the loopback from router 3, and he should, since what we have here is a configuration where all the devices are in the same area and we haven't touched any of the defaults, he should have a level 2 and a level 1 adjacency with router 2, meaning that the backbone is extended to him. So he should have in the database level 1 information and level 2 information. So let's make sure that this is the case, so we know that the device is as we expect. So we do show IP route ISIS. To see the information that's in the routing table learned from ISIS, we have the loopback for router 2, the loopback for router 3, and the link that goes between router 2 and router 3. So good, that's what we expect. Let's clean this up. So I find the yes. And let's now actually start doing configuration. Let's see what the configuration is, what we have here. We show run router ISIS, which will only give us the ISIS relevant configuration. So we don't see everything else that's there. That might end up in a lot of noise. So we have here, this is where we're defining the area. Remember that in ISIS there's no explicit area command. We have to put a net address, a CLNS net address, and in this net address we have the area, we have the system ID, and we have the network selector. So the area is 123 or 0123. So we want to make sure that router 1 is in area 0012. So what we have to do is go ahead and remove the old one and put the new one. So yes, I have to add this, the identifier, which we know is going to be loud. Say no net there. That's not what I wanted to do, but quickly fix it. We can fix it quickly. We have the technology. Remember that on XR you have to commit. If you don't commit, the configuration doesn't change. So you have to do commit, and it will tell us if it's successful, and it is. And what this is going to mean is that now router 1 is going to be in a different area from router 2, which then means that we're only going to have a level 2 adjacency with router 2. And you can see this from when we do show ISIS adjacency. See how now we have only router 2 is there. Only router 2 is there in this particular scenario. We don't have any level 1 adjacencies, because for that we would need another router to be in area. We need another router to be also in the area of 1, 2, which at this point is really none of them. So one thing I didn't do is, remember that what I was doing when we were drawing topology, that we want to make sure that router 1 and router 2 do not form a level 2 adjacency, because if you do, we're pretty much going to be in the same situation where we are going to be seeing the backbone being extended to router 1, and we want to see how does it look like from a device that doesn't have a connection to the backbone. When he's in an area and there's a board device in that area, but he doesn't have a direct connection to the backbone, or the backbone isn't extended to him. So let's do that, and when we do that, the level 2 adjacency that we have router 2 will go down, and we will be basically disconnecting router 1 from the network. So if you're doing this in the real world, just keep in mind that you can have this effect. So let's go into configuration mode, router ISIS lab. We have to use the interface, which was gigabit 0000, a lot of zeros. And then we'll specify circuit type, and here we can say level 1, level 1, 2, and level 2 only. So we want to do this as level 1. And with this, what this is going to have, the effect that this is going to have is that now there's not going to be any adjacency, because router 1 is basically signaling I can only form level 1 adjacencies. Router 2 knows I would love to, but I'm not in that area, so we will be breaking the protocol pretty badly, which results in no adjacency being formed there. When we change the configuration on router 2, we will see that this adjacency actually does come up. But you can see from this, no adjacency, so that's device. This device is now not learning anything. If we do show IP route ISIS, you can see that there's nothing there. There's nothing there because we are not speaking with anyone. We are not speaking with anyone ISIS. And here we have the configuration of our device. So we can check again. So our area is as we expect, and we have configured that on this particular interface, the circuit type will only be level 1. We can do this globally. We can do it to signal to the router that we want this device to only form level 1 adjacencies everywhere. Because, as you can imagine, if in this case all the other interfaces are admin down, but imagine that you had 96 interfaces, and they were all using ISIS. If you had to go manually specifying each one of them that, oh, you can only be level 1, that would be kind of a boring task. So you can actually just say it globally. You could say it globally and it wouldn't have this effect. Let's jump to router 2 and do the configuration here as well. Let's do show run router ISIS. By doing this, we can see that he's also in area 123. Let me clean this up. Let's modify that. So router ISIS lab. No, let's copy paste this. Remember that we have to do commit. If we don't commit, then there's no change. And let's do show ISIS adjacency. And you can see now how we're going to have a level 1 adjacency with router 1. Sorry, level 1 adjacencies. We have a level 2 adjacency with router 3. This is because now router 3 is going to be in a different area from router 2. Router 3 is going to be in area 1, 2, 3, which was the configuration that we had there in the beginning. And router 2 is now going to be in this new area 1, 2. So now router 2 is going to be acting as border. So we could actually leave it like this. We could leave it like this because it's very similar, but let's go into router 3, and just for the sake of doing what we said we were going to do in the beginning, also change it so it's actually area 3, which is what we originally wanted. So we're quickly going to router 3 as well. We shall run router ISIS. Router ISIS lab. We'll say no. Let's copy paste the net address. And in case of wondering, the system IDs here are put by hand like that, all zeros and then a 3. You could derive this from the loopback address, or you could derive it from the MAC address, or something that has more meaning to you. But I just, for the sake of simplicity, put it up all zeros.3. All zeros 3. Okay, so with this, we should change the area here. And we did commit. We didn't get an error, so it means that this is fine. It says we have a level 2 adjacency here. Well, should have done ISIS adjacencies. But yeah, this is gonna be level 2. So in theory, we should be set. Let's look at we should be set in the sense of we had the 3 devices in area 1, 2, 3. We went into each one of them and modified them, so we ended up with the diagram that we have here, which is what we wanted to do. Let's see if I can draw here. I can draw here. Good. We had router 1 and router 2 are going to be in area 1, 2, having a level 1 adjacency between them, and we previously checked that this was the case. We have area 3 for router 3, and that there's a level 2 adjacency between router 2 and router 3. Let's now do verifications. Let's check. We were doing basic verification with show IOS adjacency. Let's check the database. Let's check what's in the routing table for router 1. Which is what I want to show. Yeah. We do show IP route ISIS. So what do we have here from? What do we have here from in router 1? We have the subnets that are relevant or that exist in area 1, 2. Those are the loopback that exists in router 2 and the connection between router 2 and 3, because that interface is part of area 1, 2 as well. And we have a default route. This default route is a result of router 2 announcing the attach bit, basically signaling to devices in that area, hey, I have a connection to the backbone. So if you need to reach anything that we don't have a more specific route in place, send it over to me, basically a default network. So how does this look from the perspective of router 3? Show IP route ISIS. If we look at this from the perspective of router 3, we see that router 3 knows about everything that lives inside area 1, 2. He knows that this information was injected in the backbone, but he knows about this because by default, the level 1 information, the border device, takes all the information, all the subnets that he knows about in the level 1 area, and he creates a new LSP, a level 2 LSP, where he announces himself as the owner of this, basically signaling everyone in the backbone, hey, if you need to reach this network, send traffic my way, I know how to get them, because remember that router 2 will have those two databases. He will have the database, the level 1 database for the area, and he will have the level 2 database for the backbone. So this is why router 3 sees all of them, and from the perspective of router 1, he only sees that default. And this is because the information from the backbone doesn't get leaked by default into the level 1 areas. We just get that attached bit, so it's an optimization built into the protocol. And in fact, we have a video where we explore modifying this behavior in both directions, where you could, instead of sending, for example, all those 20 subnets, you could summarize that and just send the summary, only injecting the summary into the backbone. Because imagine that there were 100 of them. If we can summarize those into a single entry, then we are optimizing our backbone. And the smaller the database, the fastest we can get convergence. In the case of the backbone to the level 1 area, what we can actually do is that we can get the information that we need. If mind that we have some scenario with suboptimal routing. If we are in a scenario with suboptimal routing because we have multiple devices, we can actually specify something that we know that it exists in the backbone and leak that specific route. So we have a video where we go through both of those scenarios in case you're wondering. Okay, so let's check the database, which I think is the only thing that we have pending here. So let's do show ISIS database. So if we look at database, we see that the level 1 database is quite small. See the attached bit here. And the level 2 database will basically have all the information that's been sent out by router 3 and the information that router 2 is injecting there. We can see those two with more detail. But look, for example, if we do show ISIS database, and that level 2 info shouldn't be there. Let's do clear ISIS process. That's some old info there. So what we can see there is router 2 generating something, and it's because the interface, the loopback 0 is 1 and 2. So that means that he will be creating that info. But what matters here is that the level 1 database only has the information that's been announced by router 2, this information, which in this case is router 2, and obviously information that he's injecting. So there's nothing there about router 3, and this is because router 2 is blocking that, and instead using the attach bit. So let's take a peek at the level 2 on router 2. And you can see the behavior that I was talking about. Let's do clear ISIS process. We have some stale information there. Let's give it a second so it converges. But what we should see there is only the information that we know about router 3 and the information that router 2 is injected into the backbone. And that should be enough there. And you can see that basically here. So see how router 2 is taking all the information that he knows about the level 1 area, so the area 1, 2, and he's injecting it. So you can see here, this is the loopback for router 1, this is the other subnets that live in that loopback, this is the link that goes between him and router 1. And I think that's it for basic ISIS area configuration. Remember, the idea here is to, it's more complicated, the design part and the implementation part. But the idea of using areas is to optimize, is to reduce, to have the smallest possible database, so shortest path can. So when we have an event, recalculation can be quite fast. Remember that there are networks where, convergence times over a second aren't acceptable because they are financial institutions, so they do a lot of real-time trading, things of that nature where they're very time sensitive. So for that, you probably want to optimize as much as possible. And you can see how by breaking this into areas, for example, area 1, 2, the information in the database for area 1, 2 was heavily optimized because now we are reducing a lot of the info that we were getting for router 3, and imagine we have router 4 or 5 and 6, etc. This information would be summarized because the backbone area does not get injected. The info from the backbone area does not get injected into the area 1, 2 by default. So in the end, these are all techniques to optimize the protocol so we can have bigger, we can have larger networks. And as always, thank you for watching, and please don't hesitate to leave your comments below.